Hey guys, in this video I'm going to continue to review solving quadratics by factoring and some tips. First of all, I want you to note that if it has three terms, after you've checked to see if there's a big GCF, which there's not going to be at this point, you're just going to do your basic unfoiling of the quadratic. Just remember that the most important thing that you look for first is to see if the quadratic is equal to 0. So for example, on number 6, since there are three terms, we're going to go ahead and go straight into factoring. There are three terms, and we've checked that it's already set equal to 0. So x minus 5 and x plus 4 are the two factors of that quadratic. And now we're going to set each factor equal to 0. So x is equal to 5, and x is equal to negative 4. And those are the two solutions of the quadratic. Those are the two x-intercepts. Now if you look at 9 through 16, I don't know why I said 13. If you look at 9 through 16, these all have two terms. It's still a quadratic because it's degree 2, but they have two terms. So if they're two terms, you're going to look for, see if it's a GCF scenario or see if it's a difference of squares. So if we look at number 10, two terms, it looks like it's going to be a GCF that I could take out of 3x, which leaves me behind with x plus 5. I'm going to set each of my terms equal to 0, so 3x is equal to 0, and x plus 5 is equal to 0. Solve each one, so this gives me x equals 0, and x equals negative 5, and those are my two solutions. 9, 11, and 12 will also be GCF. But if you look at 13, 14, 15, and 16, all of them, of course, are all set equal to 0, so we're good to start, right? But there's no GCF for these, but they are a difference of two perfect squares. So we can't forget how to factor a difference of two perfect squares. So to factor x squared minus 64, that's x plus 8 times x minus 8, and that's equal to 0. Which means x plus 8 equals 0, x minus 8 equals 0, which means we'll get x is equal to negative 8 or x is equal to 8. And those are your two answers. Now all of these on the bottom of 17 through 22, none of these are equal to 0. So all of these have that extra first step of having to move so that you have it set equal to 0 first, then you can factor and solve. So let's take a look at number 20. Since number 20 is not set equal to 0, I'm going to go ahead and show you that let's keep the x squared positive. So let's move these to that side. Let's subtract 4x and subtract 1. And that will zero those out. So now we've got what we want. We want it set equal to 0. So it's x squared minus 14x plus 48. Now we're going to factor on the left side here, our quadratic. So factors of 48 that make 14, x minus 6, x minus 8. Set each of these equal to 0. So find the x values. The x solutions, so x is 6 and x is 8, so those are the two roots, two x-intercepts. So this was an example where we had to set it equal to 0 first. For number 22, again, this is a quadratic equation because it is a degree 2. It's not equal to 0. We're solving, we're looking for the solutions, we're looking for the x-intercepts. So it has to be set equal to 0, so I move 9 to the other side by subtracting it. So now I have my quadratic set equal to 0, and I can find the x-intercepts. By looking at this quadratic here, I can factor it using a difference of squares. And now that I factored it using a difference of squares, we can set each factor equal to 0. So I brought my work down here. Okay, set 4x plus 3 equal to 0 and solve that to get negative 3/4. And I set 4x minus 3 equal to 0 and solve that to get 3/4. So my two x-intercepts are at x equals negative 3/4 and positive 3/4.